Captain Candy Quebec was flying a routine flight from Miami to Atlanta. She had 105 passengers on board. It was May 1996. Minutes after takeoff, the plane nosedived into the Florida Everglades.
It was the day before Mother's Day. And my husband was at work, and I had gone to the grocery store to buy things that our son liked. And I was on the road coming home from grocery shopping, and the car phone rang, and it was my daughter screaming that a plane had gone down and that she felt that Jay was on that plane.
ValueJet 592 became a headline waiting for an answer. The plane, with a fire on board, crashed into the Florida swamps. There were no survivors.
That was a tragedy that was waiting to happen. All the dominoes were set up, just waiting to fall.
Buddy! Flight recorder. Got the recorder. Well, that's what we've been searching for, huh? That's one of them. One of them? That's one. What two? Which one is it? Flight data recorder.
The flight data recorder, one of the two black boxes that record the last moments of a doomed flight, is a major factor in our faith in air safety. It tells us what went wrong, and we can make sure it never happens again. After a crash, the black box becomes our memory when everyone else is dead. Whenever there's a crash, we see pictures of the flight data recorder being recovered. Finding it is like pulling the magic sword Excalibur out of the lake. We know that everything is going to be okay.
Actually, much better conditioning expected, and we're pretty optimistic the internal memory module will be intact.
We'll even search the depths of the ocean to find it. The black box is designed to be the one passenger that survives a fatal crash.
The level of sound from the pingers was so loud that they had to take their earphones off, so they know they're there.
Even if hundreds of people are dead and the plane disintegrates, we still have the information contained in the black box. We can then learn what went wrong and make sure it never happens again. The black box has become our symbol of air safety. Planes are built to fly, not to crash. So the black boxes are made to withstand the forces of impact. Whatever happens to the passengers, the precious information will be safe. The earliest black boxes scratched the information onto aluminium. A series of needles etched their data into a moving roll of foil. But as recording technology developed, the crash recorders were fitted with tape running in an endless loop, erasing what had gone before. By the 60s, digital recording was possible, and the latest black boxes store their secrets, like computers, on rows of solid-state chips.
People want to know that there was a full scientific investigation, that our government and our industry has done everything they can to determine the cause of the crash, and so that hopefully we can prevent other crashes.
Since the late 60s, planes have also had to carry voice recorders, and there is now discussion about video recorders. But the basic tool for finding out what happened to the plane is still the flight data recorder. By law, passenger planes carry both black boxes.
The black box works similar to the way the body works. The body has sensors all over to tell you sense of smell, sense of sight, touch, and so on. The airplane has the same things. In the cockpit, we have airspeed, altitude, direction, control column position, thrust lever position, autopilot control. All of these are fed by wires back to the black box. In addition to that, we have sensors on the wing itself, which tell us about the leading edge positions of the leading edge flaps, the trailing edge flaps, the ailerons, the landing gear position. And in the tail, we have elevator positions, stabilizer positions, engine parameters such as engine RPM, oil pressure, hydraulic pressure, and all of these various sensors feed into the black box, which is located in the upper rear portion of the fuselage, which is the most protected part of the aircraft. So in that way, it's just like the human brain takes senses from all over the body, puts it in the brain, and records it there.
The black box recovered from the ValueJet flight would provide the answers to what had gone wrong. At the National Transportation Safety Board in Washington, the NTSB, the black box from Flight 592 was opened to get at the information inside the crash-protected casing that holds the recording. The electronic data from the crashed flight was then played back and downloaded to a computer. All the recorded measurements of a plane's systems can be displayed either as charts or plotted on a graph second by second as they were recorded. Each line of the graph tells the investigators about one factor of the plane's behavior. With all this information, the NTSB would know what was happening on board ValueJet.
In the case of the ValueJet accident, the flight data recorder information told us a lot about the way the aircraft was behaving. We see a bump in the altitude data and a corresponding bump in the airspeed data. It showed basically an overpressure, and it was a significant event in the evolution of the fire. But the real crux of the accident really was the investigation of how the aircraft was loaded and so on and so forth.
The ValueJet flight had been illegally loaded with dangerous canisters of oxygen. The oxygen ignited as the plane took off.
Did he die of smoke inhalation? What happened with the fire? Who was he sitting next to? How long did he suffer? You don't consciously try to bring those things to mind, but they enter your mind.
The fire from the oxygen canisters burnt through the aircraft's controls, leaving the pilots completely helpless. The plane was literally a time bomb. It dived into the Everglades at over 400 miles per hour. But the flight data recorder only told the investigators how the plane had crashed. It could not tell them why. Our traditional faith in the black box and the system of air safety is being challenged. In key crash investigations, the black box has failed to deliver. Now safety experts are predicting one major air crash every week. Are we facing a crisis in air travel? Since the Boeing 737 was first launched in the 60s, over 3,000 have been sold. It has been estimated that the 737 has carried the entire world population, 6 billion people, across 92 million flight hours. Throughout the world, 737s take off and land 21,000 times a day. But for a decade, the 737 has been under suspicion. It's claimed that the plane has a potentially fatal problem, and that problem lies in the way the plane's rudder is controlled. All 737s carry black boxes, but all black boxes are not equal. A flight data recorder is only as good as the information it records. Planes have hundreds of systems that could be wired up to the black box and measured, but that doesn't mean they are. And the limitations of the black box system became all too apparent after two major crashes involving the Boeing 737. On March 3, 1991, a United 737 left Denver to make the short hop to Colorado Springs. Flight 585 had had 2 rudder incidents in the previous 2 weeks, but was now judged safe to fly. The winds from the mountains around Colorado Springs could make landing quite choppy. The locals were expecting a bumpy ride. But as the plane was lining up to land, the whole situation changed.
Oh, look at all that thick smoke. Tanya, where is it? Run to the park, dude. Run to the park? There's something caught up in the tree. I think it's part of a plane.
The 737 crashed into parkland 4 miles south of the airport, narrowly missing local houses and killing all on board instantaneously.
Sir?
They don't want anything touched.
What kind of plane is it, do you know?
Small private plane.
Private jet or something.
Small private plane?
United 585, the 737, flipped upside down and went into the ground like a rocket within 7 seconds on March 3rd of '91. My first response was, oh, this isn't for real, this doesn't happen. I'd worked for the airlines for over 20 years, and I really believed that the airline industry and the government were doing everything for air safety. I was married to the captain on that fatal flight. I just couldn't believe this was happening to us.
Captain Hal Green had 1,700 hours experience flying 737s.
Taxiway Mike and then contact ground point 7.
There had been no warning from the stricken plane. The disaster took just a matter of seconds from start to finish. The impact would last much longer.
My parents were flying in from Denver, Colorado. They were supposed to have landed at 9:40. Another lady tapped me on the shoulder, and it was her husband was on the plane, and she was crying, and she said, "They're saying the plane crashed." And I just couldn't believe that. You go into a state of shock.
Crash. 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 We're gonna crash off the airport. Crash off the airport, United 585.
You could have heard a pin drop. There was just no reaction, and I can remember looking around, and the majority of the passengers were young businessmen, and it was their wives and children.
Boeing 737, unknown reason, unknown souls, crash off the airport southeast on final to runway 35.
Flight 585 could have been equipped with a black box set up to record hundreds of measurements to tell the investigators why the plane had crashed with no warning. In fact, the black box was measuring just the legal minimum of 5 parameters, the barest details about the plane's direction, its height, its speed. The Wright brothers had recorded that much in 1903, and they made their first flight.
In the case of the United, the 5 parameters really didn't tell us a whole heck of a lot, and we didn't even have pitch attitude and roll attitude, so we didn't even know the attitude time history of the aircraft, let alone the position of the flight controls.
The investigators can use statistics from the black box recording to produce an animation showing the plane's movements. The 737 had performed virtually an aerobatic roll in the sky before crashing to the ground nose first. One factor that could have caused the 737 to flip over in the sky was the rudder. The lawyers for the victims of Flight 585 had their own views.
This is a main power control unit from the rudder of a Boeing 737. And this is the brains of it, called the servo valve. And this servo valve moves only 45 thousandths of an inch each way. And this is all the difference there is between life and death in a Boeing 737. What happens is that this slide, which only has 75 millionths of an inch clearance on each side, will jam. And if it jams, any signal to the rudder will cause the rudder to go full travel and the rudder to stop and jam there. And until this jam is released, the rudder will stay there and the aircraft will roll and roll and roll until it crashes into the ground.
The problem for the investigators was that neither the rudder nor the rudder controls on United Flight 585 were being recorded by the black box. And there was another suspect, the wind. Boeing promoted a theory based on a wind pattern called a rotor that had bounced off the mountains. Boeing claimed the rotor could have rolled the 737 out of the sky. Not everyone agreed.
The mountain was 10 miles away from the crash scene approximately, and nowhere in recorded history is there evidence that a weather phenomenon like that could maintain its strength for that amount of distance, enough to turn a 50-ton plane inverted over its side.
But without evidence about the rudder from the flight data recorder, there was no way of proving whether it was the rudder or the wind or neither. For the first time in its history, the NTSB had to say that it had failed to solve a crash. But the investigation of the 737 rudder would go on for another 5 years, and at each step of the way, the black box would be found lacking.
It's unfortunate that we would have the difficulties we have in trying to resolve accidents that are so important to the public to know the answers to, simply because we don't have data that's recorded when, in fact, it is very simple to do that.
Black boxes on many 737s still only measure a limited number of parameters. The plane was certified in 1969, when the legal requirement was less.
An older airplane that wasn't designed to have a highly sophisticated flight data recorder, you've got to install all the wiring, all the sending units, all the sensing units to be able to gather the data. It's not just a matter of pulling the old box out, putting a new one in.
And it's not just a problem of black boxes on 737s. As fleets age, so do flight data recorders.
We have upgraded older airplanes to some degree. It is very difficult, though, once an airplane is produced, to put some recording mechanisms, some parameter measuring devices inside the airplane after the fact. So there is a limit to how much you actually can retrofit into old airplanes. And so we've tried to make this balance between what is really needed to solve accidents and what is put into new airplanes just because simply when the airplane is being built, you can choose to do that.
The whole concept of the flight data recorders from the perspective of the carriers is that it's a nuisance. It costs them more to buy the airplane. It costs them more to maintain because they have to ensure that these things are operating correctly. The manufacturer is selling a product that will have the maximum performance for the minimum cost. Anything that increases the weight is a disincentive. If there's an extra pound or 5 pounds or 10 pounds that goes into a flight data recorder, that's 5 or 10 pounds that is not part of the revenue-paying load that the aircraft carries.
The regulations concerning the weight and size of flight data recorders were laid down to suit planes of an earlier age.
You look at a modern jetliner and just start looking at what's in the seat pocket in front of you in terms of weight. Okay, I'm going to pull out the in-flight catalog, mail order catalog. I'm going to pull out the in-flight magazine. Okay, I'm going to leave the safety card in because that's important. But I've got these two documents here. They're nice and thick. When you add up the weight of those magazines and catalogs and the seat backs over the whole airplane, it's the equivalent weight of one passenger. And you say, gee, we're willing to carry all this for the entertainment and amusement of the passenger. Now, what could be done for safety?
I can't even imagine what the last 6 minutes of Hausman's flight were like when there was no power and there was no lights and there was nothing. I can't even let myself go there.
These people are all victims of plane crashes.
My God, you know, all these people in a room together and they're being so graphic about body parts and conditions of bodies. And
Their organization has campaigned for upgraded flight data recorders.
No one can give me Jay back. So anyone else who goes through it, I'd like to see helped.
Unfortunately, when airplanes are falling out of the sky, then sometimes we get their attention. But it shouldn't be that way. We shouldn't have to have airplanes fall out of the sky in order to get someone's attention. They should be doing what they know they have to do to make planes as safe as possible.
Despite all our new technology, we still seem unable to stop plane crashes happening. The crash rate is not going down, and our chances of dying in an air crash are just the same today as they were 20 years ago. Throughout that time, air safety has relied on solving one crash to prevent another.
Ground scar's 105 feet long. Tail of the airplane there, nose of the airplane over here. So now we've got a mystery to solve. And let's work our way.
Traditionally, we wait until after a crash has happened and then try to find out what went wrong, rather than stopping the crash happening in the first place.
We're taking the structures apart, we're examining how they deformed when the aircraft hit the surface, and we're applying the rule-out technique, where we look at something, decide it wasn't a factor, and eliminate it from the picture. Then, hopefully, when we've ruled out everything that didn't cause the crash, what we're left with is what did. Put all this together, and we can actually explain the accident.
For years, all the information about flights has been locked away in a crash-hardened box, waiting for a crash to happen before it's used. It's called the autopsy approach to air safety.
It's like waiting till the patient is dead, gathering the data, and trying to figure out what went wrong. That approach has failed to reduce the fatal accident rate in 20 years. We got to get away from why they died and get into preventing them from dying in the first place.
As the crash rate is not going down and air travel is on the way up, there are predictions that by 2015, there will be one major crash a week.
As more people are flying and more airplanes are in the air, at a constant accident rate, more airplanes are going to be falling out of the sky. And what the industry is concerned about is that the public reacts more to events than to rates. The fact is that once a week, the public's going to be looking at, a bunch of, smashed up bodies and twisted aluminum.
Throughout the aviation industry, the new holy grail is to cut the crash rate by 80%. And the first area they are looking at is the autopsy approach and the black box. What is needed is more preventative medicine and less post-mortems. But not all air safety systems lock up their flight data in a crash-proof box, waiting for a crash to happen.
If you have quantitative information about what's going on in the innards of the aircraft while it's flying, then you have a chance to warn the pilot of difficulties that he may have no knowledge of. You do not have to wait until after it's happened. You can predict a lot of what's going on. You can sense trends.
When the US Navy are testing new fighter planes, they can monitor the information from the plane while the flight is happening. The Navy collect the data from the plane by satellite and display it to engineers. The system is called telemetry. If a crisis occurs during the test, the pilot is not on his own.
We utilized this type of telemetry system for our astronauts. And it was the major reason for bringing our astronauts safely back from the moon. This technology is now 10 or 20 years old, and there is no reason why it isn't being used on commercial aircraft all the time.
We've had aircraft being measured here that we were able to notice overheating of onboard equipment where there was no information to that effect to the pilot. The project engineer here is able to tell the pilot about the problem, what specifically to shut off and in which sequence, and he's able to return to the base safely without difficulty.
Civil airlines use telemetry to monitor their high-cost engines, and they use it for entertainment, for passenger phones and soon for email. But the high cost of bandwidth means it's not used for safety recording. If telemetry were used for passenger safety, it could mean the end of the black box.
We could take the information that's normally going to the flight recorder, and we can send that information via modern radio telemetry to the ground, and it can be recorded safely on the ground. There is no need to record the information aboard the plane.
There is no sign yet of telemetry replacing the autopsy approach to safety. The black box is with us for some time to come. And it was the black box from a second 737 crash that revealed more shortcomings in the safety system and created more problems for the NTSB. In 1994, when a US Air 737 crashed near Pittsburgh, the way that it crashed appeared to resemble the Colorado Springs disaster.
Well, I was coming down this road and I noticed a plane and it looked like it was banking. It turned and then it rolled. It just looked like it was going to do a barrel roll. Just kind of started a dive and it was, 6,000 feet in the air, and I'm watching this vertical dive of this plane, and seemed like it was in slow motion.
The 737 disintegrated as it hit the ground. 132 people died instantaneously.
She wasn't even supposed to be on that flight. She was booked on the later flight, but they finished early. When they got to the airport, they changed their flights, the people from the bank, and they ended up on 427.
By the time I got to the crash site, there were insulation, letters, and all kind of things from the plane floating in the air. And the largest piece of plane that I saw was about the size of a large pizza box. Everything else had just, in my words, minced up as it hit the ground and just shredded. There weren't any recognizable human beings. It was mostly flesh and bone. I was looking for a whole person to pull and drag out of there, and there was none.
At the time, the U.S. Air Flight 427 was the most gruesome accident I'd seen. The aircraft impacted the ground at over 300 miles an hour. It literally exploded on impact. The aircraft was severely fragmented. There were human remains literally everywhere. It was rather a horrific sight.
Bodies up there.
Once again, the flight data recorder was little help to the NTSB. Like many others installed in planes, it was recording 11 parameters. It could have been recording hundreds.
After Pittsburgh, I never want another group of investigators to have to go into the field and need data as badly as we needed it and have as little available. So I think that it's a case for full parameter flight data recorders that it is basically probably unparalleled in history.
The 132 people on the plane had been shattered into over 6,000 fragments. They could never tell what happened. The flight data recorder was also almost silent. That had little to tell. The investigators had to examine the wreckage piece by piece.
I may be wrong on that. This is a pressure switch of some sort. Yeah, pressure switch.
Somebody came out to the house and asked a lot of questions. What did she have on? What did she have with her? Things like that. There were no bodies on this plane. There were just pieces.
Despite the lack of direct evidence from the flight data recorder, the investigators were beginning to suspect the rudder.
We had a limited amount of data. We knew the physics of the aircraft, and we recreated physically what the flight control movements would have to be to get the airplane from where it was through the flight path to the ground. And you can see at this point it just enters the wake turbulence of the preceding aircraft. You notice the airplane rock back and forth. At that time, the rudder comes in, goes full deflection for that airspeed. The aircraft starts to descend. At that time also the elevator will go full nose up. And the aircraft continues in this spiral descent to the ground.
These people would have looked out one side of their windows and they would have seen nothing but trees out there. Their inner ear would have told them that the airplane is tilted, even if they were not looking out there, so they could feel the airplane rolling to the left. And once the airplane started down, the pilots attempted to recover the airplane by pulling back on the yoke, which meant that these people were squatted down in their seats as the airplane tried to pull up. And the G levels went from 1 G, like sitting here in this chair now, up to 1.5 Gs, and then it released a little bit. Then it went up to a little over 2 Gs and released a little bit, and eventually ratcheted itself up to about 3.5 Gs, which is a lot of G. Most people never experience 3.5 Gs in their life. You could hear things rattling inside the cabin. There would be things like the overhead bins, luggage, seats, all these things. As the airplane shakes, it makes a rattling noise. It would have been impending doom for these people, and it happened over a relatively long period of time. It was nearly 28 seconds, and that's a very long period of time, and you can illustrate that to yourself by just, if I were to stop now and remain silent for 28 seconds, you would think it was a near eternity.
The crash investigators knew the 737 rudder had moved, and its movement had begun the plane's fall from the sky, but they did not know why. And as the rudder and pedals were not monitored by the black box, they did not know whether the pilots had commanded the rudder or the rudder had malfunctioned.
Piedmont 3403, runway 28 center, taxi into position and hold.
2 runway 28 right, clear to land.
One thing the investigators did know was that as the 737 was coming into land at Pittsburgh, it had crossed the wake of another plane flying at the legal separation distance. Could that have somehow started off the process that led to the crash? Boeing believed that it could.
When the wake vortex theory was first brought up, people questioned, why are you doing this? This happens all the time. I mean, there must be 50, 60 times a day a 737 gets behind a 727 somewhere in the United States. If this were the case, then we should have the ground littered with 737s. And that wasn't happening. And so there must be something else going on.
$1 million test was set up. The investigators equipped a Boeing 727 with smoke generators and flew a U.S. airplane like the one that had crashed at Pittsburgh in and out of the 727's wake vortex.
The pilots involved in the investigation knew very early that any allegation that the wake turbulence of a 727 could actually roll the 737 over was just not going to be true.
However, Boeing's theory did not end there. It was not that the wake vortex had upset the plane, said Boeing, but it had upset the pilots. and they claimed their evidence came from the flight data recorder itself. The Flight 427 black box had yet another problem. There wasn't just too little data. The intervals between the data were too great. Many black boxes don't record the information often enough. Once again, missing information left the way open for other interpretations, other reasons for the crash.
If the data is only sampled once a second or once every 2 seconds, a lot of things can happen to the aircraft. Things can change very rapidly in short periods of time, and those little nuances are missed when you have low sample rates, which you do in typical flight data recorders that only record, half a dozen or a dozen parameters at a time.
The investigators were missing critical moments of the flight. The gaps between each piece of information were just holes, but what happened in those holes? The black box didn't know, but Boeing provided an explanation. Boeing claimed that during one of the gaps, the pilot had moved the rudder, and the reason he had done this, Boeing said, was because of their wake vortex theory.
Boeing took a version of that theory and said, well, the wake vortex jostled the aircraft, and that the pilots overreacted to that slight jostling, slammed the rudder pedal and held it over, in essence steering the aircraft into the ground.
The NTSB had a different view. They said that the rudder had jammed, and worse, that it had moved completely in the opposite direction to the way the pilot had intended.
To the pilot that's untrained for this event, it would appear that you're doing the right thing, but it's really going wrong. And there's no rudder deflection indicator for the pilot to see that what he's doing is making the rudder go the opposite direction.
As they approached Pittsburgh, they hit the wake and it jostled the airplane around. It moved quite a bit. Everyone felt it. And the autopilot corrected for the roll that wake caused. It wasn't enough. The crew intervened with some more wheel and still was not satisfied with getting the airplane back to wings level flight. They added a bit of right rudder, and at that point it reversed and went full left. They then faced a dilemma that no one knew at that time, that they were in a very serious condition because they could no longer stop the roll of the airplane with that rudder fully deflected. They tried. They went to absolute maximum that they could and added back pressure in an attempt to keep the nose from coming down. And as they did, they realized that the airplane was not responding as it should, and that they were facing a condition that they had never seen in all their thousands of hours of experience and years flying airplanes. And as the airplane spiraled down into the ground, they fought, trying to regain control, never succeeding and never really understanding why the airplane continued to roll.
The imprecise data from the black box was keeping the NTSB from reaching a firm conclusion. Both sides could argue exactly how they wanted.
Boeing thought it was necessary to add data in between the actual raw data points. And in this one particular instance, their interpretation had what I will call a little blip in the data. Instead of the points being connected one to another like you would on a child's drawing, point to point to point. Their interpretation had a little curvature, like a little cup, if you will, in the data. And because of that little cusp, that little cup in the data, Boeing drew the conclusion that the co-pilot had put in what we called a pulse or a double pump of the rudder, where he had put in a rudder, taken it out, and put it back in again. And from that, Boeing's inference was that the accident was caused by a pilot-induced application of full rudder.
We chose one group of curve fitting techniques, they chose another, and in some cases they kind of hand fit the data through a few data points. And when they hand fit the data, they introduced a little rudder input, and the data point wasn't there. It's not a real point that was recorded. And we took a look at all the assumed curve fitting techniques that we had, and it matched.
With the investigation stalled, the NTSB turned to a British airline for help. British Airways and other European airlines don't rely on the black box for information. They have their own recording systems, and the NTSB wanted their data about 737s. Data recordings from every British Airways flight are taken from each plane, and the information transferred to computers. Instead of waiting for a crash, the airline analyzes the information to look for potential problems that might end up as crashes. All British Airways planes carry in-flight data recorders. They aren't crash-proof, but are designed to make it easy to get at the data. They're called quick access recorders.
On a 777, there are something like 20,000 parameters available to the system. Something like 800 of them are likely to be recorded on the accident protected recorder, and maybe as many as 2,000 on the quick access recorder.
The data can be used to help to make the flight operation more efficient. The airline can check that the pilots are using the most fuel-saving methods, or that the engines are not being overstressed. But they can also use the information for safety.
The takeoff that I just did out of London is fully recorded, and I can actually look back at the data here and examine my takeoff and see that my average rotation rate, that's the speed at which the nose came off the ground, was 2.2 degrees a second, which is just right.
Remarkably, how the system first started was almost by accident. In the 1960s, British Airways' predecessor, BEA, wanted to introduce Autoland, a new automated landing system for the Trident. But to get permission from the Civil Aviation Authority, they first had to provide evidence that the system was reliable. They installed an in-flight data recorder in the Trident and began to record each landing until they had enough evidence to show that Autoland worked.
The program started as a research program, and it generated a lot of interesting statistics. And as time progressed, it became quite clear that the data was actually very, very important for safety reasons.
The information from the quick access recorder allows the airline to see patterns developing in either the plane or the pilot's behavior that may turn into accidents.
If we look at this screen, it's showing the events that occurred to the 737 fleet in 1999. It shows that the most common event was a go-around, that is when an approach has been discontinued and the aircraft climbs away again. The bit that perhaps interests us most here is deviation above the glide slope. That's when the aircraft is coming in a little bit too steeply, and we would certainly want to follow up to see if we could find out why that's happening. So we can look at this graph, which shows how many pilots have had how many events of that nature in the last year. And we see that 2 pilots did have 4 events, 3 had 3, and the rest, some had 2 and some had 1. Nobody had 10, 11 or 12, so we're quite happy that we don't have one problem pilot.
Airlines in the US are only just starting to use quick access recorders. And that failing was highlighted by what happened next.
The single valve design that is causing all these problems on the rudder is not unique to the 737 rudder. And in fact, there was a case on a 747 British Airways jet where a virtually identical valve jammed and caused the elevator to move on its own.
The 747 was leaving Heathrow, headed for Bangkok. The elevator suddenly reversed, causing the nose momentarily to pitch down. The fault went away, and the plane completed its flight safely. Data from British Airways' in-flight recorder was analyzed. This time there was proof. It was a valve failure.
If it hadn't been for all the parameters we had and be able to look at this, that had been only an 11 parameter recorder, the event would have been set aside as a wake turbulence encounter or turbulence or just some other anomaly that came and went, because certainly it happened over very few seconds and didn't occur again for the rest of the flight. That showed the value of the data.
The hydraulic system for the elevators of all 747-400s was redesigned because of the evidence from the quick access recorder. In the 747 incident, the problem was found and put right before anybody died. By not locking up the data, a crash was prevented rather than simply being explained. 40 years after British Airways introduced quick access recorders, the American government is still trying to persuade their airlines to install them. If the 737 rudder movements had been recorded by in-flight recorders, then the Colorado Springs and Pittsburgh crashes may have been avoided. Despite the failings of the black box, the world's biggest passenger plane industry is still placing its faith in the autopsy approach.
It doesn't take a whole lot for things to go drastically wrong very quickly. And so there is an interest in capturing this data and to know what is going on. And the fact that the British are doing this, I think, is just absolutely commendable. And the fact that we are years behind is something of a national embarrassment.
Finally, 8 years after Colorado Springs, and without the evidence from the black box, the NTSB called for a redesign of the 737 rudder control system.
The dual concentric servo valve used in all Boeing 737 main rudder power control units is not reliably redundant.
The NTSB also called for the controls of the 737 rudder to be wired up to the black box. Boeing say they have made frequent and significant modifications to the rudder design on the 737, and that the plane is safe, and that the rudder is now reliable. They were invited to take part in this program, but declined to be interviewed.
If there were another 737 accident similar to Pittsburgh or something like that, I think the repercussions would be incredible. That there's certainly the passenger confidence in the aircraft would be almost destroyed. And so if another accident were to occur, I would expect that there'd be a lot of empty 737s either sitting on the ground or flying.
The lack of black box data has left the world's most used plane under suspicion. And waiting for crashes to happen has not made the skies safer. The black box has not brought the crash rate down, and there are predictions of one major crash a week.
When I buy a ticket or you buy a ticket, you're buying a journey from point A to point B, and you don't want any perturbations in that trip, and you damn sure don't want that ticket to be a death sentence.
The limitations of the black box dragged out the 737 investigation over 8 years, and on many planes, the black box still records an inadequate amount of flight data. There will always be a need for information, the data that can save lives. But if we want to fly, we have to use that data to prevent crashes, not just to solve them.